precipitation, and the difference between QSP and KSP. So what is KSP? We know KSP is the product ion concentrations at equilibrium, product of ion concentration. So KSP is basically, if I'm working with A, B, it dissociates, it gives me A and B ion, right? Let's say A plus and B minus. So KSP is the product of concentration of ions at equilibrium, whereas Q, which is called as the reaction quotient, QSP is going to be the same expression, A concentration, B concentration, but these concentrations are under any conditions at any given time. It does not have to be equilibrium. Q is the product of ion concentration under any conditions, basically meaning at any given time point. What is the significance of knowing Q? Q can help us determine if a compound is going to precipitate or not. We can figure that out by comparing QSP versus KSP. Anytime there's a question about is this salt going to precipitate or is this compound going to precipitate or not, the answer lies in the comparison of QSP versus KSP. For example, AgCl gives Ag plus Cl. KSP is going to be Ag concentration, Cl concentration, each at equilibrium, whereas QSP is going to be same Ag concentration times Cl concentration, but at any given time point. Now, how can we predict the formation of a precipitate? The formation of precipitate, now remember, QSP is also product concentration over reactant concentration, and QSP and KSP always are comparable to each other. Whenever QSP is equal to KSP, that means reaction is at equilibrium, so the solution is saturated. In case of dissolution of solids, as whenever a solution is saturated, we say QSP is equal to KSP, and QSP always wants to become equal to KSP. So if QSP is a smaller value, that means when would QSP be small? When product concentration is less. So product concentration is less, which means reaction wants to make more products, so the reaction will try to go towards more product. This is when your solution is unsaturated, which means it is not going to precipitate. So when Q is less than K, the solution is unsaturated, like here. More solid will turn into ions. When Q is equal to K, the solution is at equilibrium, which means if we add more solid, it is going to precipitate. And when Q is greater than KSP, that simply means that when QSP, Q again is product over reactant, when Q is a big number, that means we have lot of product. So reaction wants to have less product so that it can become equal to K. How can it become less product? It will go towards solid. So this is when precipitation will occur. So whenever Q is greater than K, precipitation occurs. So if a question is simply asking, will a precipitate form under these concentrations or not, the answer is we find Q first, we compare QSP and KSP, and we find which one's greater or are they equal to each other. So when Q is less than K, solution is unsaturated, so there is no precipitate. When Q is equal to K, solution is saturated, but there is no precipitate. When Q is greater than K, that's when the solution is super saturated and it is going to form a precipitate. For instance, let's try a question. One form of kidney stone is calcium phosphate, which has KSP of this. A sample contains 1 times 10 raised to the minus 3 calcium ion concentration and this much of phosphate ion concentration. Predict whether calcium phosphate will precipitate or not. Again, the question is, will it precipitate or not? There's no other way but to find QSP. So QSP is going to be for calcium phosphate. For this, first I need what is calcium phosphate going to dissociate to? This is going to dissociate to give us 3 calcium ion and 2 phosphate ion, which means QSP is going to be calcium ion concentration cubed and phosphate ion concentration squared. So it's 3 minus squared because of the coefficient, right? Calcium is 3 and phosphate is 2. And the concentration of calcium is given to me, so I'm just going to plug in 1.0 times 10 raised to the power minus 3 cubed times 1.0 times 10 raised to the power minus 8 squared for phosphate. And we solve for these concentrations and then we compare it to KSP. When we solve this, the Q comes out to be 1.0 times 10 raised to the power minus 25. KSP is 1.0 times 10 raised to the power minus 6, which means Q is a greater number than KSP, which tells you that the precipitate will form. When Q is big, precipitate will form. When Q is less, no precipitate will form. The last question was when directly the concentrations were given. This is another type of question. A common lab method for preparing a precipitate is to mix two solutions containing the component ions. Does a precipitate form when 0.1 liters of 0.3 molar calcium nitrate is mixed with 0.2 liters of 0.06 molar sodium fluoride? KSP is given for calcium fluoride, which means I'm mixing two solutions, calcium nitrate and sodium fluoride, and the KSP is calcium fluoride. So I'm interested in which salt? Calcium fluoride. Calcium fluoride will dissociate to give me 1 calcium ion and 2 fluoride ions. So if I want QSP of this salt, I need calcium ion concentration times fluoride ion concentration squared. Now the calcium ion concentration is given to you indirectly. The question says you added 0.1 liter of 0.3 molar calcium, and fluoride is given right here. We added 0.2 liter of 0.06 molar fluoride, but these concentrations were initial concentrations. This is what was added. For QSP, I need the concentration which is at this given time point, which means I have to find the calcium ion concentration after mixing. So the initial concentration, which this is dilution because we started with 0.1 liter of 0.3 molar calcium nitrate, but then we added 0.2 liters of sodium fluoride into it. So I changed the volume of my solution, which means M1V1 equals M2V2. So initial concentration is 0.30, initial volume is 0.100 liters. I'm interested in finding what is the final molarity when the final volume is 0.1 plus 0.2. So we added these two, 0.1 of this, 0.2, so total is 0.300 liters. So my molarity is going to be 0.30 times 0.100 liter divided by 0.300 liter, which gives me 0.10 molar. That is my M2, which means my calcium ion is 0.10. Similarly, we will find fluoride ion concentration. Same approach, M1V1 equal M2V2. In this case, M2 is going to be 0.60 M times 0.200 liter divided by 0.300 liter. Liter gone, my final answer is molarity, which gives me 0.04 molar. So fluoride is 0.040 whole squared. You solve for this and we find what is QSP. After QSP, we compare it to KSP. So if we solve for each There is another question, example question for you guys to try. The answer is on the slide. Same approach. Will a precipitate of PbI2 form when 100 ml of 0.05 molar Pb nitrate are mixed with 200 ml of 0.10 molar NaI? So Pb is coming from this, I is coming from this, and Ksp of PbI2 is given. So we will find what is Qsp of PbI2 by using lead concentration from here, M1V1 M2V2, and iodide concentration from here, M1V1 equal M2V2. Please try this question on your own, and the answer is already given to you, so I'll play the answer right here, but please try the question on your own. We use the same approach. Final volume is 300 ml. M1V1 divided by V2 gives me M2. This is lead. Same thing I do for iodide. This is the iodide concentration. Then we find QSP for each, and then we compare Q and KSP. And this is what is precipitation, QSP versus KSP.